Hello, I'm Graham Lewis. In this short video we're going to look at a trickier tree diagram question where we're given some probabilities and we have to work out which parts of the branch they're on. So here we've got Fiona and she's preparing her energy drink in the morning. She's got an 80% chance of being on time to a fitness class if she prepares her drink. So if she prepares her drink, then she's got an 80% chance. So let's just think about that. If she prepares her drink, then the chance of her being on time is actually 80%. So she has to prepare the drink first. I'll put a P for prepare. If she does not prepare the drink, so imagine now she does not prepare the drink, then she has a chance of being late of 60%. Okay, so thinking about that, we've got two options. We can either prepare the drink and not prepare the drink first, and we could be on time and late first. Because these are conditional on preparing the drink or not preparing the drink, you want to put the time and late on the second branches and preparing the drink and not preparing the drink at the first one. I hope that makes sense. So using that idea, because that's the tricky thing here, she's either going to prepare the drink or not prepare the drink. So P complement. If she prepares the drink, she's either going to be on time or late. You could have put a T dash there if you wanted. She's either going to be on time or late. And now let's put some of the numbers in here. So if Fiona prepares her drink in the morning, so I'm here, she has an 80% chance of being on time. So I'll write a 0.8 there for the 80%. If she does not prepare a drink, so I'm going down the bottom branch, she has a chance of being late by 60%. So I'll put a 0.6 there. Fiona prepares an energy drink every 5 out of 7 days. So the probability she prepares an energy drink is 5/7. So not would be 2/7. So if the probability of being on time here is 0.8, because this branch and this branch have to add up to 1, if she prepares the drink, the probability of being late must be 0.2, because 0.2 at 0.8 is 1. Equally, if she does not prepare the drink, she can either be late or on time. So these two branches have to add to 1. So that must be a 0.4. Phew! Check the question again, read it, make sure it fits in, and once you're happy, we can answer A. So part A, what's the probability that she's on time? Well, she could prepare her drink and be on time, or not prepare her drink and be on time. So the probability of her being on time is actually the probability of preparing the drink and being on time, or the probability of not preparing the drink and being on time. So the ands there are multiplied, so it's 5/7. Remember, multiply the branches together, times 0.8 plus, and then here 2/7 times 0.4. And I'm going to enter 0.8 as 4/5 in my calculator so I can get a nice fraction out of this, because 0.8 is 4/5. And I'm going to enter 0.4 as 2/5 in my calculator and get an answer. So I'm just going to throw that in the calculator and get an answer. So I whopped that badger into my calculator and it came out with 24/35. And that's the answer of Fiona being on time to her fitness class. So part B, if Fiona tries to go to her fitness class 150 times in a year, how many times is she on time? So, well, the probability of her being on time is 24 out of 35. So every 35 times she goes, she'd be on time 24, and obviously 11 of the times she'd be late. So all we need to do is take the 24/35, the probability, multiply it by the 150, and let's see what that gives. So 24, I think it's a decimal, so you can think about what we would do if we get a decimal answer here. So 24, we get a decimal answer, I'm right, of 102.86 to 2 decimal places. So you can either leave it as a decimal and say Fiona would expect to be on time 102.86 times, or you could choose to say she definitely make it on time 102 times, but not quite the 103rd time. And so you decide how you want to finish that question in context. Okay, thank you very much for watching and good luck with your probability. I hope this has helped.